Hello, hello, hello. At what time? 6, 7. Tengo, solo de mi set como las 7:30. Well, I could just try to skip it. Look. Hello, Jamie.
No, I'm here. It's just Luca broke her foot, so I have to take her everywhere.
No, I was thinking. That's what I was telling him. I was like, bro, I don't know. You should probably take Eric. I might take Eric. Work?
I'm still have a graphic on this. Because I don't remember it from like
You had him? Well, you did.
I tried.
Yeah. Was that your first time? Was it your first time? He said out of nowhere?
And he would tell me like stories in like 10 minutes.
Like one
Or he's trying to
the one time I don't have that.
I've never had him. I don't have him.
Tom is the worst.
Good morning, ladies and gentlemen. How are we doing today? Good, wonderful, awesome, excellent, ladies and gentlemen. Take out your computers, get logged in. While you are doing that, what do the 4 quantum numbers represent about an electron, ladies and gentlemen? That's our question of the day. That's what we're going to answer in just a moment. So, Joshua, Achilles, where are you at? There he was. All right, Shenza. Yep. Pierce. Yep. Jack. Yes.
But I'm not allowed to do this. Teachers in that. Well, she's just afraid of me.
I keep talking so
All right, 4 quantum numbers describe every electron around the nucleus of an atom. Tell me what one of those 4 quantum numbers represents. Okay, the orbital, the orientation of it. Okay, the orientation of it. Which phone away, please, sir? Okay, thank you. Phones away, people. Let's go. Headphones out. Good, Josh. What do you got?
The amount of electrons.
There is actually no quantum number that represents the amount of them. The amount is based off of different things. Do you remember what the amount was based off of? Technically, the orientations of the sublevels. So the orientations of the sublevels can tell us how many electrons total because 2 electrons fit in each one. So good, Josie.
Does the azimuthal count or reverse count?
The azimuthal is the orientation. Okay, what else? So Phoebe gave us the sublevel, the orientation of the sublevel, 2 more.
The energy level?
The principal quantum number representing the energy level, and then the final one representing the
spin.
The spin. Which direction is it spinning? So for spinning, they use 2 ways to represent that. They use clockwise and counterclockwise. Okay? Could call it spinning to the left, spinning to the right. Whatever it is, there are 2 opposite directions that it can spin. So only 2 electrons can ever fit in any orientation of a sublevel. That is the maximum. Why? If you got more than that in there, 2 of them would have to be spinning in the same direction. Now you cannot have 4 unique quantum numbers. Okay? Questions? All right. So we left you yesterday with showing you how these quantum numbers related to the periodic table. Okay? Hang on. It's coming. So, your periodic table, ladies and gentlemen, actually helps you to understand this. Okay? Now, over here, these first 2 groups, they are called the S block, meaning these are the 4S part of, or these are the S part of your energy level. Okay? So, let's go back a minute. Let's go back a minute. All right. So, to start with, number 1, we have the principal quantum number. The principal quantum number is represented by the symbol N. And N can be from what to what? 1 through 7. Okay? So N can be from 1 through 7. Here's 1. Here's 2. Here's 3. Here's 4. Here's 5. Here's 6. Here's 7. This is part of 6. This is part of 7. Okay? Then we have the subsidiary quantum number. The subsidiary represents the sublevel. Every energy level has a different amount of sublevels. We use the term L to describe it. And L's value are from 0 to N minus 1. So every energy level has at least a 0 sublevel. But then if N equals 1, you get 0. If N equals 2, you get 0 and 1. If N equals 3, you get 0, 1, and 2. And if N equals 4, you get 0, 1, 2, and 3. So what this means is if we kept going, we would get to 5, 6, and 7 energy levels. We would have 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 5. Now, here's the fact. We never go more than this. No energy level has more than 4 sublevels right now. Some don't have that many. The first level only has 1 sublevel. It doesn't have 2. It only has 1. Why? So close to the nucleus, there is not room for a second sublevel. When you get to the second energy level, you get two sublevels, represented by the numbers 0 and 1. You get 3 in the third, represented by 0, 1, and 2. And you get 4 in the fourth, represented by 0, 1, 2, and 3. You will never have more than that. Okay? You will never have more than that. So, what that means is that the further you get away from the nucleus, the more room you have for electrons, the more space you have for them. Now remember, they're called quantum numbers. So everything has to be a number. So the n values are 1 to 7. The values for L are 0, 0, 1, 0, 1, 2, 0, 1, 2, 3. So you take a combination of this and these and put them together, and that's 2 of the 4 quantum numbers that you would get describing an electron. So this is the state, meaning Wisconsin, Illinois, Indiana. Then this is the city. Where within that state are they? So this is the energy level. Where within that energy level are they? Now in a minute, ladies and gentlemen, we're going to learn, or we already introduced this to you, but if you have a 0 for a sublevel, we are going to represent that by the letter S. If you have a 1 for a sublevel, we are going to represent that with the letter P. If you have a 2 for the sublevel, we represent that with a D. And if you have a 3, we represent that with an F, ladies and gentlemen. Okay? Now, you cannot have F sublevel until what energy level? Four. So prior to energy level 4, there is no F sublevel. There's no room for them. They don't exist. They're not there. Until you get to level 3, the whats don't exist. What sublevel first exists in the D, or in the third sublevel? Third energy level. What? D. So you cannot have D's until the third energy level. In the first level, you only have S's. There are no P's even in there. Second level, you have S's and you have P's. Okay? After the first level, second on, every level has S's and P's. After the third level, every level has S's, P's, and D's. After the fourth level, every level has S's, P's, D's, and F's. Now, they may not all get used, but they exist. Questions? Now, the third quantum number. The third quantum number, ladies and gentlemen, is the azimuthal. That means orientation. Okay? That is based on the L value, but we give it the symbol M. And it is from negative L to L. That's how we find the values. So if L equals 0, the values of M are 1. There's only one thing there. Okay, sorry, it should be 0. Sorry. 0 to negative 0 would be 0. Which means for this S sublevel, there's only one orientation of it. 1. That's it. Here's a model of it right there. It's a sphere. No matter how I turn this in space, that sphere looks exactly the same way. That's why there's only one orientation of this. No matter how you look at it, it will appear the same every single time. Questions? Now, in the second energy level, there is another sphere like that, but it must be a little bit what? There it is. Because this is inside of this. And the nucleus of the atom is inside of that. These are just the area where electrons would be. And in this area, there are 2 electrons maximum. 2. That's it. Somewhere in there moving around. Okay? Now, if your L value equals 1, now the M's are -1, 0, and 1. 3 orientations, 3 ways in space to look at the shape of that sublevel. There it is. Along the what axis? Nope. X. Along the and along the Z. That one's coming at you, Phoebe. That one's coming at you. This one's going across. That's okay.
It's okay, girl.
By the way, why the white part in the center? That's where this is. These electrons can't all be in the same place. If they're all in the same place, they're going to be running into each other, repelling each other, causing problems. So in the center of all 3 of these is this. And what you have to understand is that these are all occurring at the same time. So around this one shape, you have this area on the sides of it, on the x-axis, this on the y-axis, up and down, and this coming at you and going away from you on the z-axis. Z, X, Y, Z.
I don't know the numbers.
Right, the numbers X, Y, and Z, ladies and gentlemen. Okay? This is the way that the electrons can stay away from each other. In this area between these 2, they call it a barbell. Don't ask me why. I guess somebody thought it looked like a barbell. Okay? In these 2 areas, around the nucleus, there are 2 electrons total. Somewhere in here, moving around. Same thing here. There are 2 electrons somewhere in here and here moving around.
2 in each.
2 total.
Oh, okay.
So one may be up here, one may be up here. They could both be up here. They could both be down here. But somewhere in this area, that's where 2 electrons are. And they're always moving around. So when we look at their image, we see this shape. So we know they're somewhere in here. So we're pretty confident that this is what it looks like. And then they could be in front or behind. Again, 2 electrons somewhere in this area, in this shape. Okay? Now, we get to the D's, which the L value would be a 2. For M, then, we get -2, -1, 0, 1, and 2. And it scares me to even do this, ladies and gentlemen. But here we go. Somewhere in these 4 regions, you're going to find 2 electrons. Somewhere in those 4. Now, you'll notice when I hold it like this, I'm sorry, I've now switched the axis on you. Okay? They're not in the z-axis, which is going out and back, right? And they're not on the x-axis, which is going across. Why? Because these are already there. These are already there. So now as we get a little bigger, we got to find another space. So these are not along the x, they're not along the y, they're not along the z. They're somewhere in between. These are like this. Again, in between, but not on that z-axis coming out at you, not on the x-axis going across, they are in between. And then we have another set that looks like this that would be going in the 90 degrees opposite of it. Okay? So that's 3 of them. here's the fourth one. And if you really want to get funky, ladies and gentlemen, here's the fifth one. So somewhere in this like wheel part here could be a couple of electrons or could be out here. Okay? Now, I am not expecting you to memorize them. I don't expect you to understand them. I'm not going to ask you about what axis they are. But what you do need to understand is there is one orientation of an S, always. One, meaning it can hold 2 electrons. Okay? Dude, why are you hanging on to his sweatshirt for him? You're scaring me. Okay? Keep your hands to yourself. For the P's, there are 3 different orientations. 3 orientations means 6 electrons. 1 orientation means 2. 5 orientations means 10. And they can't even make models of the F's. But there are 14 different ways they are orientated, or 7 different ways they are orientated in space. Okay? So, again, as the atom gets bigger, there is more room for these regions, if you will, these sublevels. Okay? All right. Now, these are called the S block over here, ladies and gentlemen. And the reason they are called the S block is because this is where the first 2 electrons will go for any energy level. Now, in the first level, there's only 2 of them. So this one over here is over here because this first level only holds 2 electrons. But after that, every level starts out with the S block, we call it, which can hold 2 electrons. So this one is S1. This one would be S2. Why S1? Because there's only 1 electron here. Why S2? Because there are 2 electrons in the S part of the second energy level, of the third energy level, of the fourth. Over here, ladies and gentlemen, are what are called the P block. The P block represents these 3 orientations and the 6 electrons that can fit in it. So there are 6 families over here. Okay? 6 families. Now, electrons still always want to what each other? Repel. So we have these 3 orientations along the X, along the Y, and along the Z, correct? So if I start putting electrons in there, if I put 1 electron, it'll go into one of these. When I put the second electron, where does it go? Correct. It is called Hund's rule. Hund's rule is one of the yellow ones on your periodic table. I believe Hun is on there, isn't he? Or not? I could be mistaken on that. Was Hun on there or no? Nope. Okay, sorry. Hund's rule says that electrons fill singly first, then doubly. So what you just said, Phoebe, is absolutely correct, and you knew Hund's rule before you even knew what Hund's rule was. Hund's rule says that rather than pair up in one orientation, okay, they're going to go singly first. 1 in here, 1 in here, 1 in here. Okay, now if you put in a 4th one, you've got 1 in all 3. Now you will start doubling up somewhere. Okay, now you can't do that with S's. Why?
There's 2
Because there's,
electrons.
well, there are 2 electrons.
Oh, yeah.
Why can't you do that with S's? Yes, sir.
Look, I think I left my water fountain in the back.
Okay, we'll check. Is it behind Shenza there? All right, here you go. Why can't you fill singly first, then doubly with the S's? What? They're repelling everyone. That's the reason we do singly first, then doubly. How many orientations are there in a P? Sublevel. How many? How many? Three. Fill singly first, then doubly. How many orientations are there in an S sublevel? One. One. Guess what? You can't do singly first, then doubly when there's only one place to put them. You put one in, then you put the second one in. So singly first, doubly only applies to P's or D's and F's. To P's, D's, and F's. Why? Because you have multiple orientations where you can keep them separated for a longer period of time. Now, it is entirely and completely up to you, ladies and gentlemen. But it might be a good idea on a periodic table. Let's find one from before. For you to do something like this, ladies and gentlemen. On your periodic table, whichever favorite one you have, because I know some of you have so many. I think Angel's got 17,384 of them. But I'm not counting. Let's get rid of this stuff. All right, let's zoom out. The periodic table is going to help you with a lot of what we are about to do, ladies and gentlemen, but it can only help you if you have certain things on it. So right here by group 1 at the top above hydrogen, I am going to put S1. Any element in group 1, when you are describing their electrons, will end S1. Meaning they will be in the whatever energy level, the S part of it, and there will only be one electron in there. By the second group, I'm going to put S2. And I'm also going to put a note above hydrogen, or in helium. I'm going to write S2 in there as well. I wrote it actually in there because this is the only one in this family that ends in S2. The only one. Okay? So that's S2 I wrote in there. S with a 2 as a power. Good. Now that Josie has everybody's attention, I should have said that earlier. The numbers are written as exponential powers. S1, S2. Okay? Now, above boron, I am going to write P1. Above carbon, I am going to write P2. Above nitrogen, P3. Above oxygen, P4. Above fluorine, P5. And I am going to go above the noble gases and do P6. The only one that wouldn't end that way is which? Helium, which would end S2. Questions?
Wait, so you did P2 for carbon, P3 for nitrogen?
P4 for oxygen, P5 for fluorine, P6 for the noble gases. Questions? All right. So now, above 3, group 3, those are the which ones? What? D. So above group 3, D1. Above group 4, D2. Above group 5, D3. Above group 6, D4. All the way, D5, D6, D7, D8, D9, and I should finish with D10. Josie.
Do they always have to be in lowercase letters?
Yes. Always have to be in lowercase letters. Great question. Good job. Good job. So S, P, D, and F are always written in lowercase letters. Questions? What's the problem, Phoebe?
What's the charge of board?
I don't care.
Okay.
I don't care. We're not talking about charges right now. Technically, its charge would be a -5
Oh,
because it can't be a +3 because it's a non-metal.
Yeah.
But we don't care about that right now. Okay? We don't care about that right now. But you know what you did just help me remember, Phoebe? Is we will now be able to explain why some of these transition metals have multiple charges. We'll be able to show you that in a little bit. Okay? Now, the only thing we have left are the what? The Fs. Now, I'm going to put the Fs above down here. How many total F electrons are there? In the S's, there were 2. In the, hold on, in the P's, there were 6. In the D's, there were 10. In the F's, there are 14. 14. So I'm going to start way over here above element 71. And I'm going to put F14. Start there. Do not start on the other end. You will see why when we are done. And I am now going to work backwards. Over 70, I'm going to put F13. Over 69, I'm going to put F12. And I am going to keep working backwards. And you are going to tell me where you end, ladies and gentlemen. So you tell me what happened when you did that, ladies and gentlemen. What?
There's a 0.
Can't have 0.
Just.
Nope. You're right. When you do it, we end up with one that doesn't have an F over it. Anyone know why?
Because it goes right there.
So what should it have above it?
A D.
Very good. Very good, Phoebe. These are the D1 that actually belong right here and here. Right here and here. Questions? All right. Your periodic table's about to get uglier, ladies and gentlemen, and just when you were thinking that probably isn't possible, well, yeah, it's going to. Now, the problem that we have here, ladies and gentlemen, is I'm going to switch my analogy here a little bit on you. We're going to talk about a parking garage. Multi-level parking garage. You pull into a multi-level parking garage. Where do most people park?
The first floor.
Thank God he's not in our multi-level parking garage. Most people take the first level because it's the closest
To the road.
and they park there, correct? Why do people go to the second level?
Because the first is too back.
Because the first level is full. Why do they go to the third level?
It's like this.
Good. So basically, people are lazy. We want to put as least amount of effort into something as we can. So we want to take the closest spots, then we go to the next closest, then we go to the next closest, and so on and so forth, right? Okay. Well, electrons aren't lazy. but electrons want to go to where it takes the least amount of energy. And that happens to be the first energy level. So they fill it up. But if it's full, what do they have to do?
Go to a different energy level.
Go to what energy level?
The first.
The first
Second-
one's
I mean, no,
full.
The second one. The second
They
one.
go to the second one. Okay? But in the second one, there are two sublevels for them to choose between. S's and P's. Which ones fill first? S. Why? No.
Less.
Why did they go to the first energy level and not the second? So why would they go to an S before they would fill a P? Uses less energy. Now, you may not be able to see this from where you're sitting, ladies and gentlemen, so if not, move your butts and take the rest of you with it. This yellow part down here represents the first energy level. There is only one sub-level in it, and that is the S. So the electrons have to go into here. This represents the second energy level, and the S's are down here and the P's are up here, which means the S's have what kind of energy compared to the P's? Less, because as we go up higher and higher, what does this say? Energy is increasing, correct? Right?
No.
So the reason that the two S's fill before the two P's is it takes less energy to fill them. The electrons will fill the lower energy first, then they will have to fill the higher energy afterwards. Here's the third level. In the third level, what sublevels do we have?
D.
What?
D.
And?
S. Oh, S.
Well, let's start with what has to be in every level. A what? An S. In the third level, there would also be,
S.
we just said S.
Oh.
P. And D.
Oh.
Here's the S. Here's the P. Where are the D? Right? Look at the poster. Where are the D's?
On the right.
In the middle.
Way up here. Why?
Because it's more efficient.
No, because they have more what than the S's or the P's? More energy. More energy. But you'll notice they are a little bit higher than what? Than the four S's. The four S's actually take less energy to fill than the three D's. So we always fill from the lowest energy up. So the four S's will actually fill before the three D's. Then, after the three D's are filled, you'll get the four P's, right? Well, look at your periodic table. The S's appear in the, the D's appear in the third energy level, correct? The third energy level. But in the third energy level of our periodic table, how many elements are there? Count them.
8.
1, 2, 3, 4, 5, 6, 7, 8. Those are the S's. Those are the P's. Where are the D's? What? Where are the three D's? The 10 over there. Come on up here and show me, Shenza. Hurry up, come on.
I see from there all the way go to Z.
So these are three D's? You're absolutely right. Which, by the way, just happened to be after, what are these? Which S's? What energy level is this?
Oh, this is
4.
Right after the four S's, here come the three D's. They fill after the 4s's because they have higher energy than the 4s's. So even though these, scandium through zinc, even though they are in the 4th energy level, they are actually the 3Ds. These are the 3Ds. These are the 4Ds. What does that make this here? The 5D and 6Ds. The Ds fill one behind. In other words, even though they're in the 4th energy level, it's the 3Ds that are filling afterwards here. In between the 4s's and the 4p's. Questions? Seems confusing. Will get easier. I know. Yay. When do the F's first have enough space to be a sublevel? What energy level finally gets F's? 4. 4. First level, S's. Second level, S's and P's. Third level, S, P's, and D's. Fourth level, S, P, D, and F. Okay, let's go back to our chart here. Four S, 3 D's, 4 P's. After the 4 P's, 5 S. Then what? 4 D's, 5 P's. Still no F's yet. 6 S, 4 F's, 5 D. Here, the D's were how many behind? The 3 D's are in what energy level? 4. The F's, the 4 F's, are in what energy level? So the D's were 1 behind, the F's 2 behind. So the F's don't appear until what energy level? Or don't start filling. They appear in the 4th energy level, but they don't start filling until the 6th. The what? The 6th? So that would mean that these down here belong right there where they're supposed to be, ladies and gentlemen.
Oh, that makes sense.
Right there where they're supposed to be. And since these are in the 7th energy level here, these are the which F's? If they're 2 behind. Can't be the 7F. That's the 7th energy level. 5 F's. Now, before you write this down, wait a minute, because you got to make sure you get this in the right spot, because you only get one shot here. So the D's filled 1 behind, correct? The F's are filling 2 behind, right? Okay. So in the 6th energy level, what F's are these? If they're 2 behind. In the 6th energy level, what F's are these if they're 2 behind? 4 F's. Which element is the 4F?
PM.
Where are you getting PM? Nope, too far. You're already into the 4th F there. Where is the first F in period 6? What element is the first F in period 6? CE, not LA. This is the 4F. So what would be LA? No, look above it. What? What D1? D's are how many behind?
1.
1. So if it's in the 6th energy level, what D is that? This is 5D. This is 5D, followed by 4F. So what goes by thorium?
5.
5F. What goes by actinium?
6.
6D. All right, good. We got that down. Questions? You want to try that louder, Josie?
Miss Walkowski is filling up her Stanley.
Her Stanley?
Yeah, her cup.
She's got a guy named Stanley?
Okay.
What? Bukowski's got some guy? What? What? So seriously, no questions. This is all clear.
IG.
I have brain fog.
Okay, well, all right. I guess since you got this down, there's nothing to do but move forward. This is just a little graphic for you, ladies and gentlemen. Everything that you are about to see on it is explained in your periodic table, but this is called the Aufbau filling order. Okay? And here's what it says. You'll notice in first energy level, there is only 1 S's. In the second energy level, there is 2 S and 2 P. In the third energy level, there is 3 S, 3 P, and 3 D, correct? In the fourth energy level, there is 4 S, 4 P, 4 D, and 4 F. And that is the way it is from there on out. Okay? By the way, we've never gotten to the 8th energy level yet, correct? Okay, good. So this was just a diagram that Aufbau came up with as a way of remembering what is called the filling order. You go S1, then you come back and you go 2S, then you come back and you go 2 Ps, then 3 S's, 3 D or 3 Ps, 4 S's. Now, this to me doesn't help me one bit. Doesn't help me one bit. This does. 1S1, 1S2. 2S2, 2P6, 3S2, 3P6, 4S2.
Was that right? 4-3D?
What?
No, that's not right.
What did you say?
I said 4-3D.
How do you get 4-3D?
Because isn't that the 3Ds right there?
Okay, so say that.
Yeah, I said 3D.
You said 4-3.
Oh, yeah, 3D.
3D what? 10. Then what? Okay. These were which P's?
4 Ps. Oh, 4 Ps.
So,
4S.
4S, 2.
6. 5S2. 4D.
4D10.
5P6.
6S.
6S2.
6S2. Now, gets a little funky here. Gets a little funky here. What is this spot?
That's the
4F.
Try again.
5D.
5D.
Oh,
5.
5D1. But then what happens?
4F.
4F.
14.
14.
oh.
Now, if you were to be asked for an element in here, If you don't put that 5d1 in, you're going to come up 1 electron short. However, if you go all the way through these, do these completely fill before the D's completely fill? In other words, after this one, what would be the next element that you would go to? What D's? Those are not 6 D's. What?
6.
No, those are not 6. Those are back to 5 D's. So, if we get all the way through these 4 F's, we would list them first in our order. And then we would go back to the 5 D's. Now, once we get to here, what is this? 5D what? Okay, then what are these? 6 P's. The periodic table lays that filling order out for you, ladies and gentlemen. It lays it out for you. All you've got to be able to do is follow the pattern here. Follow the pattern here. Questions? Boy, I still see a lot of confused looks. So let's get through the next part, ladies and gentlemen. This is going to become easier. Trust me. Trust me.
Wait, the last thing you just showed us, the off-bow thing.
Off-bow, yeah.
Is it okay if we understand that one better than what you just showed us?
Well, I don't care.
Because that one makes more sense to me.
Okay, but it's the same thing that I just showed you, which was this. After we do the 4 S's, we do the 3 D's. Same thing that was on the periodic table. Here are the 4 S's. Here are the 3 D's. Right? What are these? Which P's? 4 P's. Off bow. 4S, 3D, 4P. What's next after the 4 P's? 5S. Off bow. 5S. 4 D's. No, I don't want that. Here's the 5 D's or 5 S's, 4 D's. It's the same thing. Now it's going to go back to that stupid thing. They're both telling you the same thing, Josie. If you want to write that down and use that, I have absolutely no problem with it. No problem whatsoever. Questions? All right. So now let's start doing this. How many electrons does hydrogen have?
Uno.
How many in English?
Oh,
I don't
1.
speak French, sorry.
1.
1. So where's that 1 electron going to go, ladies and gentlemen? Which S? There's multiple S's up here. What? Which S1? You're beginning with the second part of the quantum number, the S. Let's begin with the first part, the energy level. What energy level does that 1 electron go in? Okay. Now, I don't know if I have this so that you can do this or not, ladies and gentlemen, but I'm going to put an arrow in here, and I'm going to put the arrow going one direction. I don't care which direction. I'm going to put 1 arrow in here. So that is what that 1 electron would look like, correct? So if I want to describe the electron configuration, the configuration is 1, S, 1. Do you understand why?
Why it's up?
What?
Like why the arrows up?
What does the arrow represent?
Not clockwise.
Correct. It represents the spin, but it also represents a what? An electron. Since there's only one electron total in hydrogen, it has to be in the 1s, and it has to be spinning one of the two directions. I don't care if you put an up arrow or a down arrow. It doesn't matter. Okay? It's got to be spinning one of the two directions. So now if I'm describing all of the electrons, 1s1. That's it. One electron, first energy level, s sublevel. There's only one orientation of the sublevel. Now, that is a lot better than having to write out this, ladies and gentlemen. 1, 0, 0, 1. Or actually, sorry, it's a number. It's a number. It's a number. Does anybody remember what numbers we used to represent the spins? We also could do +1/2. Now, would you rather write out all four of these or this? These two are taken by this. The S's, there's only one orientation of them. So it's telling you that this is the 0 sublevel, and there's only one orientation of it. This is telling you one electron spinning one direction. Okay? Questions? Okay. How many electrons does helium have?
2.
2. Where's the first one go? Come on. Where's the first one go? 1s. Where's the second one go?
2s.
No.
No, wait.
Too high energy. Too high energy. Where does the next electron go? No. Too high energy. No, there is no 1p.
1s.
Goes into the 1s. Why? How many electrons will it hold?
2.
2. What would be the configuration? 1s 2. Which is a lot better than having to write this. These are the 4 quantum numbers that would technically give you this. Which way is easier? This or this? Please don't all answer at once. Would you rather write this or this? Because I can let you do it either way. Which one do you want to do it?
The first.
Good. That's a good choice. It's a good choice. Good choice. Okay, so now we go to lithium. How many electrons? Where'd the first 2 go? Which S? 1s. So lithium starts out looking a lot like helium. Boom. Boom. Where does the third one go?
2s.
Again, I don't care which way you put them, but they can't be going the same direction. Okay? So, describe the configuration for me. Where are all the electrons? How do we begin?
2.
Nope. One S. Now what?
2s 1.
One S2, 2S1. I'm not even going to try writing these anymore. What element is next? Beryllium. First 2 electrons go here. 4 electrons total, correct? Where does the next one go?
2s.
Where does the next one go?
2s.
Describe the configuration.
1s2.
Where's the first of boron's 5 electrons go? Come on, we got to make this quicker, people. Second one. Third one. Fourth one. Fifth one. Write the configuration.
2s2.
What element was that? Sorry, and it's not going to let me do that. If I go back to my other one, I'm going to lose all my writing on there.
That's kind of cute.
So, here's boron. What number do we have written above it? E1. What period is it in? What? It's in the second period, so we end 2p1. Exactly what we just wrote, correct? Exactly what we just wrote. Next, carbon. How many electrons?
6.
6. Let's do the first 4. I know where those go. Where's the 5th one go? Where's the 6th one go?
2p.
Here? Nope. Singly first, then doubly. Singly first, then doubly. 1s2, 2s2. How do we finish? Come on. Two P2. Now, technically, ladies and gentlemen, we're not going to get that technical. But technically, these two P's, one is in the X and one is in the Y. I don't know, maybe one's in the Y, one's in the Z. Maybe one's in the X, one's in the... I know they're in separate ones, I don't know which. Okay? But we always fill singly first and then doubly. Questions? All right, nitrogen. How many electrons?
7.
1, 2, 3, 4, 5, 6. Where does the 7th go?
2p.
X, Y, or Z?
Y.
Nope.
Z.
Singly first, then doubly. Configuration, what do we got? We fade it off.
2p2. 3.
1,
Oh,
2,
yeah.
3. By the way, how many electrons total? 2 plus 2 plus 3 is?
7.
7. The numbers in your powers better add up to the total number of electrons, otherwise you're wrong. Oxygen. 1, 2, 3, 4. 8 electrons. 5, 6, 7. Where does the 8th one go? 2p1. Now you got to go start pairing them up. There's no other place to go. Why don't you go to the 3s? because it's a higher energy level. It would take more energy to do it. They go to the lower energy. Configuration. 2p4. Fluorine, 9 electrons. 1, 2, 3, 4, 5, 6, 7. Oops, that was ugly. 7, 8. Where's number 9 go? I don't care if you put it in 2py or 2pz. Doesn't matter. Just got to be singly first. Configuration. 2p5. Neon, 10 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Configuration.
2p6.
Questions? What would sodium's configuration be? What should it start with? What's next? By the way, how many electrons are we trying to place?
11.
So 1s2, 2s2, 2p2,
2p6. 1.
Think about that. Why are you going back to 1? Mr. Brand? Yes. Sure, I'll send her down. Okay, thank you. Morgan, you need to go see the nurse. What? Very good. Hey, looky there. Isn't that the spot that it's in on the periodic table? These are S1s. 3. Your element tells you how it's going to end based on where it's at, right? Questions? Oh, good. Let's do this then. Phosphorus, how many electrons total?
15.
How many?
15.
15. Okay, give me the configuration. What? Why the hell are you starting 2s1 when we've started every one of these 1s something? 1s2. Why is it 1s2? Well, because the first energy level is filled, and that's how the first energy level looks when it's filled. What's next? 2s2. What's next? What? Nope. 2p6. What's next? 3s2. What's next? 3p3. 3p3. Here's phosphorus. P3. Third energy level has to end 3p3. Questions? You're scaring me, ladies and gentlemen. You really are. Argon. How many electrons? All right. Give me some configuration.
2s2, 2s2, 3s2,
2, 4, 10, 12, 18. Perfect. Questions? Okay, who can give me copper? Okay, you're all alone, Josie. Keep going.
I can't.
Josie, you're packing up, so you must understand this. You must be done. Come on. What's next? Phoebe's apparently jumping in to help you. Phoebe, what's next?
2s2.
Good. 2s2. Then what, Phoebe? You'll notice Josie's leaving you completely out on the limb on your own.
2p6.
Okay, what's next?
3s2. And then 3p6. 4s2. And then
You are so close.
3d9.
What?
3d9. Oh yeah.
Oh, yeah. Oh, yeah. So, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, then you missed the D here, Phoebe. 3d9. 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 That is electron configurations, ladies and gentlemen. Okay? That is electron configurations. Now, the quantum numbers are how we got to this. They are the model that lets us do this. Okay? What we're doing now is we are describing every electron around the nucleus of the atom. What energy level is it in? What sublevel is it in? Now, we don't go directly into orientations, but we should understand that for the S, there's only one orientation. For the P, there are 3. For the D's, there are 5. And then we're telling you how many electrons are in that area, that region, that orientation of that sublevel. Questions, ladies and gentlemen?